Hello, and welcome to Bytesized Godot, a series covering technical aspects and development tips for the Godot game engine. I'm Bryce Dixon, a professional game programmer with over a decade of game development experience ranging from solo projects to AAA studios. Today I wanted to create a follow-up video to my last episode covering signals and coroutines with a few more advanced concepts, problems, and my preferred solutions. The first problem we have here is simple. I have four functions, f1, f2, g1, and g2, where f2 is dependent on f1 and g2 is dependent on g1, but either sequence isn't necessarily related to the other. This current solution isn't ideal because the g sequence can't start until both f1 and f2 are complete, despite not being dependent on them, but if we just move the g sequence to run before the f sequence, we'd have the exact same problem in reverse. Ideally, we craft a solution which ensures f2 runs after f1 is complete and that g2 runs after g1 is complete, but neither is dependent on the other. Here I've created a function called awaitSequence, which takes a list of potentially asynchronous callables to invoke in order. With this, I can define the linear sequences of asynchronously calling f1 into f2, and g1 into g2, without needing to halt the calling main function to wait for any of them, since awaitSequence itself is a coroutine we are intentionally not awaiting. We can see from the output that this way, g1 and g2 are able to start before f1 has finished, but that f2 is also able to finish before g2, as we've successfully decoupled these two sequences. For the next problem, I'm going to ask that you use a bit of imagination. All three of these signals are emitted after a timer expires, but really they can be anything, and I think a good example is to imagine a screen which can be closed by any player pressing OK, or if a time limit expires. The core problem is that our code is inherently linear. We can't await multiple signals in the same place, and while we could connect them all to the same callable, which would disconnect them all when it's called, I personally find this solution a bit messy and hard to conceptualize and maintain. What we want is to create a new signal which we can await, which acts as the logical union of all three of our signals. In other words, one that's emitted if any of them are emitted. However, we can't create new signal definitions at runtime, but we can create new objects and emit a signal on that. Since every signal is actually tied to a specific object instance, we can effectively create our own anonymous signals in the same way that lambdas are anonymous functions by creating a generic class type which effectively only contains a signal. From here, we can really easily connect a list of signals to our dynamic signal to effectively forward their emission to a more generic signal. The engine will also clean up the connections for us since the dynamic signal frees itself once its signal is emitted. One sneaky thing I'm doing here is having any signal return a signal rather than await it directly, so that the caller can decide how it gets used. It's a bit more complicated, but we can do something similar for only emitting our generic signal if all of the dependent signals have been emitted rather than any of them. One example of where this could be used is waiting for all players to mark themselves as ready before continuing, but not expecting any specific order of those signals. For example, before I had all these players emitting their signal in the order of 1, 2, 3, but it still works even though now it is 2, 3, 1. With that, I've covered everything I wanted to for this episode, so thank you for watching. I've left links to the relevant documentation in the description for further reading. If you'd like to suggest a topic for a future video, please do so at the list linked in the description.